This is how a car engine works. Let's start at a single piston, the powerhouse of the engine, and work our way outwards. The four-stroke cycle. When a piston travels to the end of its range, whether up or down, that's a stroke. Car engines use a four-stroke cycle, and it goes like this. First, intake. The piston descends, sucking an air-fuel mixture into the cylinder through the intake port, with both intake valves open. Next, compression. With all valves closed, the piston comes back up, compressing the fuel and air mixture for more powerful combustion. Then, the power stroke. An electrical spark ignites the compressed fuel and air mixture, and the resulting combustion forces the piston to the bottom of the cylinder again. A connecting rod transfers this power to the crankshaft. Finally, exhaust. The piston comes back up, pushing the spent mixture out through open exhaust valves and the exhaust port, connecting multiple pistons. For smooth power delivery, pistons take turns firing. The firing order for this engine is 1, 3, 4, 2. Camshafts with specially shaped cams push spring-loaded valves open in turn. Cam gears and a timing belt or chain links everything to the crankshaft, and it all spins together. The crankshaft translates piston power out of the engine. It has counterweights to balance against the pistons for perfectly smooth revolutions. This is what RPM means. We're counting the number of full crankshaft revolutions per minute. The engine block holds the crankshaft and cylinders, and the cylinder head holds valves, ports, cams, etc. A geared flywheel sits at one side of the crankshaft for connection to a transmission. It's also where the starter connects to the system. This engine has 4 cylinders arranged in a single row, but there are many other possible configurations, like 6 cylinders with 3 on each side, angled in a V shape, or 8. Despite different design goals, the basic engine parts are all there. Now let's look at other systems that support this combustion process. Air in